Okay, hi, welcome. Добрый день. Yeah, sorry, my Russian isn't that good, so I have to continue in English. Okay, so before I actually start, a bit of a warning, because this talk is a bit abstract, sorry, so I hope you stay with me and you stay awake, right? I mean, it's about architecture, and architecture in its nature is a bit abstract. I tried to make this as easy and funny as possible, but still, we're talking about architecture. Okay, so warning said, you're still here, that's good. So, today I want to give you a guide of how you can design a clean architecture. And I think when we talk about architecture, there are two fundamentally very different approaches available. On the one hand, we have this cool, fancy new way of a microservices architecture, right? And on the other hand, there is this old, boring way of a monolithic architecture. Well, for me, I prefer to make a decision based on facts. And yes, it is a fact that microservices have a lot of advantages. But these advantages also come at a price. There is some added amount of complexity. And when I say like, there is some added amount of complexity, I very often hear, oh, it's not much, right? Well, for me as a clean coder, I will always fight any kind of unneeded complexity. I will just not tolerate any kind of complexity that is unneeded. So when possible, before I jump the microservices train, I will see if I can solve the problem just as well with a much more simpler monolithic architecture. And this is what I want to show you today. Okay, so, but before I go more in detail, just quickly a few words about myself. So, my name is Biel. I'm a clean code evangelist. Well, that's a big word. It just means that I'm really passionate about clean code. And to keep this quick, besides lots of other stuff, I do work as a clean code coach and a Java consultant. Okay, enough about myself. So, to talk about an architecture, I think we first of all have to talk about architecture in general. But yeah, again, to keep this not as boring and to like directly come to the point, I think when we talk about an architecture, what I usually see when we're in a team, we're standing together in front of a whiteboard. Let's assume this is our whiteboard, right? And then when we talk about the architecture, we usually do so by describing of how the entire system looks like with something like these boxes, right? And we draw of how these boxes are connected in some way or the other. As this example, I tried to make this as simple as ever possible. Because from my personal experience, that's exactly what happens. These overviews are usually very, very simple and nice. Everything good, happy, happy. Well, unfortunately, the reality in the majority of cases is something else. So why is that? For this, I see two reasons. First of all, this is just a high-level overview. So from a high-level overview, this might be correct. But architecture is more than just a high-level overview. Architecture is all about these fine, small details. And I will tell you much more about these small details that matter a lot. So on a high-level overview, that might be correct. But still, this is still the reality. Second, we might start with a simple idea when we start designing our system. So everything in the beginning of the project is simple. But then, you know, the business guys, they add more and more features. And so what's started very simple and clear, sooner or later ends like this, as a big ball of mud. Yeah, and I'm sure everyone here in the room has seen a system like this, has felt the pain of this, what this really means. I mean, this is just a graphic, but there is pain involved, right? And this, in essence, is what we try to avoid when we are creating a clean architecture. Okay, so how can we achieve that? Well, I think, in essence, the way of how we can achieve that, the secret here is in these boxes. We have to get these boxes right. and we have to get the connections right. And that, in essence, is what modularity is all about. Or you could also call it divide and conquer, right? I mean, divide and conquer is a principle that is, I guess, a few thousand years old. I think it even comes from the Romans. So divide and conquer, or call it modularity, for me, from an abstract point of view, that's the same thing. We have to get this right, and this is a super, super powerful concept. To illustrate this, I brought you this image of the little boy playing with Lego. I think Lego is a great example of modularity, because one simple Lego cube doesn't do much. But putting all these Lego cubes together, we can build really great stuff. And even adults play with Lego, right? This concept made the Lego company a multi-billion-dollar company. So this shows how powerful this concept is, and it also shows the concept of modularity is not restricted only to programming. This is a concept that is generally used in the humanity. This is how we as the humans solve problems, right? We have a very complex problem that is too complex to directly tackle. So we split it up into smaller units, and every unit even smaller until every problem is so simple that we can easily solve it. That is all about modularity. And so, to me, the secret to achieve a clean architecture lies within achieving a clean modular architecture. So we have to get this right. And if you look at a programming language like Java, Java itself is modular to the core. We have methods, classes, packages, and now with Java 9, hooray, we even have modules. Well, modules even have the name of modularity, right? So they show us this is about modularity. In a talk, I will very often say component and not module, because I don't want to confuse you. I mean, we have modules everywhere, but to differentiate between modules, I will speak of components, but it's just like the same thing. It is about splitting up functionality into smaller subunits. So let's look at this more in detail. We have all this hierarchy here, right? You could also call this layers. Well, layers is just a different word, from my point of view at least, to the abstract idea of modularity, of splitting up complexity, of solving the problem, right? And when you further look at this hierarchy, you will see, well, you have the top and the bottom, and you will understand, well, modules usually consist of packages. Packages, again, consist of classes. Classes, again, exist of methods. So the small units are the ones that matter the most. But also the whole system matters. We have to look at the entire system, and we have to get everything clean. That is how we can achieve a clean architecture. Okay, so before I continue talking about this, to give you a little break, I thought, let's give you a sneak peek of what we're trying to achieve in the very, very end. Well, I gave you the promise. I want to give you a guide of how you can design a clean architecture. I will need a lot of stuff that I will tell you of how we can achieve that. This I'll do starting in the next slide. But once we have this knowledge, we will start from top down. We need some approach of how we start designing our system. And we usually do so by choosing some design approach of how we want to design our system. There are several available. I have chosen here the hexagonal architecture because it has lots of advantages that will help us towards a clean architecture. I would hope you know a bit about hexagonal architecture. If you do, that's a great help, right? But if you don't, it's not a problem because it doesn't matter so much. I just wanted to mention, we need some concept, some idea. But it's still very high level. So the small details, as I said, matter much more. So what matters here to me is hexagonal architecture is a layered architecture. So we have layers again, right? And if you remember the graphic from the beginning, you saw that I said, well, over time, there were more and more dependencies added. So we somehow have to fix that problem. We have to technically enforce that the design stays as we were intending it to be. And here, we need to fix somehow the layers. We want the dependencies to go from the outside in. And we want to have the domain really separated from all these dirty infrastructure details. The way we can achieve that is by using Java 9 modules. So we had a lot of talks already about Java 9 modules just before from Sander. So I hope you know a bit about Java 9 modules. We'll not go in more detail. I just want to mention the way we achieve that is by really separating the two layers, by encapsulating them, by using Java 9 modules. Now, the second thing that matters to me a lot towards achieving a clean architecture, and I think Rabea also mentioned it, we have to keep the domain and the infrastructure details as separate from each other as possible, which hexagonal architecture can help us a lot with. So this is all you need to know. On top, maybe I could mention the blue hexagon that we also see here. That's how we can later, if we need to, scale up our approach towards a microservices architecture. But still, this talk is telling you of how we can avoid that. But later, that need might appear, and we can use the same approach. Okay, so now I want to give you a foundation of the building blocks that we actually need to achieve a clean modular architecture. And to me, the two most important building blocks here are coupling and cohesion. Later, I'll also give you some other building blocks, but let's start with these guys. And let's talk about coupling first. So, first question, what is coupling in detail? Coupling is about two or more components. It is, again, about the idea, splitting up complexity into smaller subunits to make the complexity better digestible, right? But when we do so, these components will be coupled in some way or the other. So that is coupling. I sometimes even hear or read, coupling is bad. Well, if coupling was bad, just think all the connections are gone. Then we don't have a system, right? We have 6 distinct systems. So this is not helpful. We do need coupling. Coupling is like a drug. To a certain amount, it's okay. But too much of it, and it will be a problem. So the question is the amount of coupling. If we have a system, a tightly coupled system, what we call a big ball of mud, we have, first of all, lots of connections, lots of dependencies. So that can be a problem, as I'll show you in a second. But it's not only about the number of connections, it's also about the strength of the connections. I try to visualize this here by making the lines really solid and strong, right? While in a loosely coupled system, they're really thin and nice and dotted. The strength of the connection, of the coupling, again, is a huge topic, and I'll tell you more in the next slides. So this much for now. But again, why is coupling a problem, or why can coupling be a problem? Let's assume we're changing one component, in this case, the yellow component. If the yellow component changes, well, there are other components that are depending on it. And because there are other components that are depending on it, there is a risk, a chance, that the other components might also change. And this chance, this risk, is the higher, the more tighter this coupling is, obviously, right? And in the case of a tightly coupled system, there are even not only direct connections, but also a lot of indirect connections. So that in a tightly coupled system, in a big ball of mud, one simple change might lead to a rippling change, rippling through the entire system. And this is when the pain starts, right? This is what we have to avoid. In a loosely coupled system, however, we see here we have the yellow component again, and there is just one component that is directly coupled to it. And it's like the strength of the coupling is really loose. So there is a chance that we have a change, but it might be small. In the best case, there is no change at all. That would be great, but we can't guarantee that. Second, it's also about the knowledge required. Because if you have one component and its functionality depends on the functionality of a different component, well then obviously to understand of how the component works, you have to understand bits of how the other component works. And you have to understand the more tighter this coupling is. So then it can be really difficult. In the case of our tightly coupled system, I guess we don't really have distinct systems anymore. This is so tightly coupled together that we have to understand always the entire system. And our initial idea to split up the functionality, divide and conquer, is gone. We don't have distinct systems anymore. This is so tightly coupled, we always have to touch and understand the entire system. So this is why we try to avoid a tightly coupled system. Okay, so far I was just making a simplification. I was just speaking of tight and loose coupling. Well, this is not entirely true, because coupling is not a binary attribute. It is a sliding scale. And, well, I'm also not a native English speaker, so for me the sliding scale word is a bit weird. And you might have the same problem, maybe. So to illustrate this here, I gave you this long bar, right? To really illustrate, there's many factors in between. So it's not just tight and loose coupling. Coupling is really complex to talk about and to reason about. So we have to look a bit more in detail about the strengths of the coupling. Again, there is many factors that influence the strengths of the coupling. And I could do the entire talk only talking about factors of the strengths of coupling. So I just picked 3 examples here that I think are interesting to look at. The first one is the distance of the components. Okay, let's look at this. Again, here we have the hierarchy, right? So the question is, if we speak of 2 components, are there 2 very large modules, very distinct modules, or are we speaking of 2 small methods in the same class? That does make a difference, because the more bigger everything gets, the more complex everything gets, the more code is involved, and the more people are usually involved. And this can easily get a social problem even, because now you have to communicate with others when things change, right? So this is when this can easily get risky, and we try to avoid risk, obviously, right? So this is why the higher you are in our hierarchy, looking at 2 components, the more you will strive towards a very loose form of coupling. While the more lower you are, if we're looking at 2 methods, a more tighter form of coupling might be acceptable, because it's not black and white, it always has a price. Nothing comes for free, so we always have to have a balance and see what do we want to choose. Let me illustrate this. We could speak of synchronous form of coupling, or we could also have an asynchronous form of coupling. Well, asynchronous form of coupling has a lot of advantages. Let me show you this. So here we have a sender component and a receiver component. The sender sends a message to something like a message queue. So this decouples the 2 components in time. If there's a problem in sending or receiving, the sender can send the message again, and the receiver can receive the message again. Well, that's cool, right? That's an advantage, that helps. So let's use it. Well, unfortunately, again, this comes at a price, because it comes with some added amount of complexity. And yeah, I hear you, it's not much. But again, when it comes to complexity, I really have 0 tolerance. So really we have to ask ourselves, do we need that or not? And if we're speaking of 2 large modules, very distinct, then this might be a great approach. Especially also when we talk of 2 different microservices, this might be probably a good approach, because it's about the risk. If there's many people involved, and this is a social thing, because they might not properly talk to each other, or it might just be take a lot of time, well then this flexibility is a great advantage. But if there's just 2 small methods, this mightn't help much. So we have to take this into account. Okay, so to further illustrate this, here the principle of try, don't repeat yourself, right? So we try to avoid duplicating code. Sure, but so the question again is the distance of the 2 components that are involved. Are we speaking of 2 small components that are very close to each other, which I try to illustrate here by having the same kind of blue color? Well, so they have the same kind of functionality, and this might be a problem. And we might want to fix this. So now they're sharing this functionality. But now we replaced one problem, and we introduced a new problem, because now we coupled the two components. And the question is that a problem or not? Well, if they're close and small, probably everything good. But what if they're super large modules, very complex, and many of them, and they are in very distinct areas? In domain-driven design, we usually speak of they are in different bounded contexts, right? So in this case, coupling all these components together might be a really bad idea. And we would probably prefer to go separate ways, as it's called in domain-driven design. So this is one of the few decisions that you have to make when you design a clean architecture. I wish I could really give you the one answer. I really love, like, rule of thumb, first, second, third, this is how you do it. But this is not how a clean architecture works. You can't solve a complex problem with a simple solution. There's lots of decisions that you have to make. There's lots of informed decisions that you have to make. And you continuously have to make these decisions. Okay, so another factor when it comes to the strengths of the coupling is also, like, how does the connection look like? How many parameters are we sending and or receiving? Are we just sending one simple string? Or are we sending many parameters and very complex ones? You could think of an entire collection of very complex objects. Well, obviously, the more we send and or receive, and the more complex, the more tighter our coupling gets. And we should strive to make this simple. Well, obviously, this is driven by the business needs. But still, you know, usually we can argue a bit, and we can see, is this really needed? And we should, like, question this. Can we make this simpler? Because this will improve the coupling. But again, it's not so simple, because there might also be other factors involved. Like, for example, performance, or the readability of your code. So as long as you make an informed decision and you decide, well, at the given time, in my given case, I'm aware of the consequences, I'm aware of the price that I pay here for this kind of coupling, and I make this informed decision now, this is probably okay. I just want you to make informed decisions. Because very, very often with my colleagues, I hear, doesn't matter, let's just do it. It works, great. But this is not how you can achieve a clean architecture. You really have to put a lot of passion and emotion in this and a lot of thought. And this is not easy. Okay, the last factor when it comes to the coupling that I want to talk about is the timing of the coupling. The question is, how do we couple our two components? Do we couple them at runtime or at compile time? Well, obviously, the later we couple them, great, right? Flexibility, I love flexibility. But it's not so easy again. It comes at a price. Because if you use something like dependency injection, Spring, right? Everyone knows that, everyone uses that, we love that. But if you couple the two components and you couple them at runtime, you might see a problem between the two components, in the worst case, on production. And that might be causing severe problems, right? And you have to be aware of that. So again, you have to make a decision. Do I need that or not? In the case of our hexagonal architecture and our two different layers, that's probably a great idea. But you would probably not use this all the time. You have to make a decision. Okay, so that's everything I want to tell you about coupling. Now I want to tell you more about cohesion. When you look at coupling and cohesion, to me, cohesion is actually the more important factor. This really is the cornerstone, the secret key towards a clean architecture. Let's see why. So first of all, what is cohesion? Well, cohesion is about one component. It is about the activities within that component. How closely related are the activities, the responsibilities, the functionalities within that component? I try to illustrate that again with colors to make it simple, right? In our highly cohesive system, I grouped all the colors nicely together, while in our low cohesive system, everything looks a bit disorganized. So Cohesion is about sorting, grouping, organizing. And if you think about architecture, isn't architecture exactly about that, about structure and organization? And that's why cohesion is really the cornerstone of an architecture, of a clean architecture. So, if you look at cohesion and coupling, cohesion, I said, is the more important one. Because if you have a low cohesive system, it will usually tend towards also a really strong form of coupling. Why is that? Well, if you look at the colors and you see, for example, the blue color, well, here it's disorganized and the blue color is spread over the entire system. Let's say the blue color represents car functionality. We could think of a wheel, steering wheel, and an engine. They somehow have to talk to each other, right? Well, if this functionality is spread over the entire system, this talking will involve a lot of coupling, dependencies. So this is why a low cohesive system tends also towards a really tightly coupled system. Well, it's not so simple, because then I would just say, forget about coupling, let's just focus on cohesion and everything is good. No, it's not. Because coupling, we talked a bit about the strengths of the coupling, it's more. So we also have to look at coupling. But if you start with something, and if you have to make a decision, I would always favor looking at cohesion first. This will help us a lot. Let's say getting cohesion right will give you a clean system by 80% already. Okay, so with cohesion it's a sliding scale. We don't just have low and high, there's many levels in between. So let's also illustrate this further and look into this a bit more in detail. So here I brought you a component and I gave it the name general utils. This could be a class, could be a module, right? Cohesion applies on all levels. And cohesion also, you have to look at the entire system. It's not enough to look just at one component, right? But this is a bit difficult to explain, so here we will look at one component. Just keep in mind, it's always of how the entire system works, of how the entire hierarchy works. You can only achieve a really high cohesive system if you look at the entire system, obviously. So, if it helps you, think of general utils as a class. Just keep in mind it might be a module also. General utils, the name is already a bit bad, right? This should give you a hint, and we'll look at this more in detail later also. Here we have functionality like create customer, validate car, and write report. Well, again, I try to illustrate this with color. It's really unrelated. This is the lowest cohesion you could think of. There is no cohesion. This is just thrown together in some funny way. So this we should obviously avoid under all circumstances. So let's improve this. Now we have created a customer service. We have some business functionality here, and we're focusing on a customer. This is much better already. We're selling to a customer, invoicing to a customer, we're helping a customer. But still, there's different functionalities, different responsibilities, right? It's about selling, invoicing, and helping. So we can further improve this. We can further make this higher cohesive by splitting this up. Now we have 3 components: customer sales, customer accounting, customer service. This is just one responsibility. So should we always do that? No, it's not so easy, because now we have 3 components instead of 1. This comes at a price. So we really have to make an informed decision. And we have to, maybe you start with that. And if that's simple and clean, testable, maintainable, this is probably the way to go. You don't have to always split this up. And you might change your opinion later on, because it might get more complex over time. Well, then refactor the code, touch the code, change the code. This is how you do it. Okay, so now I said cohesion is about sorting, grouping, and organizing. Well, by what do we sort? There is a criteria, right? And when it comes to a criteria, we could sort by anything we like, right? But again, to keep this short, I think the 2 most important ones are logical cohesion and business cohesion. If we are in a system that uses an approach like I showed you, hexagonal architecture, perfect. We have business functionality and the technical details perfectly separated. But usually it's not so easy. We are in a different system and everything is a bit mingled. And then I very often hear questions like, should I sort my packages by feature or by layer? Funny enough, that question was answered in a book from 1974. So you see also this topic of coupling, cohesion, modularity is super, super old. This is far from being new, but it's more important than ever. They started to discuss these topics in the context of programming about 60 years ago. So, if you have to make such a decision, let me answer this question for you. Well, programming is a lot of fun, yes, but obviously we're making it for a reason. We're trying to solve a problem for a business. So our software is a model of what the real world looks like, right? And they're somehow mapped. So we should map them as close as possible, because we want that if there is a change or a new feature added in the business, that at most this requires one change in our software. So the way we can achieve this is we have to strive for business cohesion. This is much more important. So if you have to make this decision, try to achieve business cohesion. The business is really what matters, and this is why domain-driven design is really so important. This is all about domain-driven design. This is what it teaches you. So if you haven't read the book from Eric Evans, highly recommend you to read this. Okay, so to finish off with talking about cohesion, I want to tell you, like I said, this is really hard. But why is that so hard? Well, I said we should strive for cohesion, and we should strive for cohesion based on business knowledge, right? But how can you do that? You need that knowledge. And when you join a new company, when you join a new team, the business that you're working in might exist for hundreds of years. There's a lot of knowledge that you have to acquire. And even worse, right? The knowledge will usually not be just in a book that you can pick up and read and you know everything. The knowledge will be spread over several sources. And to make this even more difficult, the knowledge will be spread over several people. And this knowledge is their sacred value. This is the value they have on the company. So if you are the new girl or guy, why would they want to share this knowledge with you, right? So you have to, this is social, you have to make them open up to you. You have to talk to them. You have to really be friends with them as close as possible. This is very social, and usually the knowledge is even spread over several people. They might disagree. So really difficult, and you have to agree in your team. So this is why social topics really matter. You cannot achieve a clean architecture if the social things don't work in the team. This is what I would really focus a lot to achieve a clean architecture. Okay. So, now that I talked about coupling and cohesion, I also want to talk about some other building blocks that really matter. The first one is encapsulation. So, what is encapsulation? That's actually funny. When you ask like 10 developers, I guess you will get 12 different answers what encapsulation is all about. So here's my definition. Encapsulation is the implementation of information hiding. So it's also about abstraction. It's about simplification. We're hiding certain things. In this way, we're doing two things. First of all, we're documenting our intentions. We're saying to the next developer, please don't touch this, touch that, right? On top, it technically enforces what we want. This is great, right? Because if we think back to the graphic of the big ball of mud that I showed you, now we have modules. They technically enforce that it stays as encapsulated as we wanted it to be. So this is a great help. This is a great help for us humans. It's always about the humans, right? Because computers, they don't need encapsulation. It's about us humans, because we have a problem with complexity, and it helps us to understand the complexity. When I started learning about Java, I read a book, and this book said encapsulation is about getters and setters. You have your private attributes and you have your public getters and setters, and that is encapsulation. Well, I never understood this. And it took me a while to understand, well, actually, I'm right to not understand this because it just doesn't make sense. I know some might disagree. I hope you're not. If you do, or if you just want to know more, I have here a link where you can read more details of why I think getters and setters are really evil. But here in short, well, we made the fields private, right? Because we didn't want them to be touched. Now, if we add getters and setters, we directly allow you to access these fields again. So this counters our whole idea. And this is why getters and setters are evil. We want to think in functionality. We don't want to think in data. If you think in data and if you write code like this, you don't have an object-oriented system. You have what Martin Fowler calls an anemic system. This is far from being clean. So please avoid getters and setters. And they're not what encapsulation is about. Not at all. And to close talking about encapsulation, here's one small tip that I think really matters. Use package private way more often. I think it unfairly is hardly ever used. So why is that? Well, package private is there when we don't put any modifier. So when we do that, usually the next developer will think, oh, he or she forgot to add the modifier, right? And then they fix our problem and they add public or private in front. So when you do use public package private, please add a comment. You did this on purpose and why, so that this doesn't get fixed. But still, I owe you the answer, like why is package private so cool? Here, just a quick example. Think of a class BMW. Well, I do drive a BMW. BMW is cool. I'm from Munich, right? So I don't want anyone to like touch my BMW, right? Unfortunately, a public method can be touched from anyone. Now, if you have a public method inspection, anyone could run an inspection on my private BMW. Might not be such a great idea, right? So maybe it's a better idea to make such an inspection method package private. And if you have the BMW class and the BMW package, not only the BMW engineer will be able to run the inspection on your BMW. Might be better. So package private can be used on a class level, on a method level, even on an interface level. Using package private allows you to really nicely design even an API within a package. You can design classes that you want to be used outside of the package, and you can have other classes that you don't want to be used outside of the package. So make use of package private. It's awesome. Okay, so that much about encapsulation. Now about naming. Okay. I think I talked slightly about names already. And I said we will talk about this again. Clean names really matter towards achieving high cohesion. If you have a component and you give it the name general utils, what does general utils do? If you're new, working in a new system, the first thing that you will see is the name, right? You have not opened the class module whatsoever, you just see the name. And if that component is called general utils, what will be your imagination this component does? General, something, utils, something else, something, something. So really something, very unspecific. And this is exactly what happens over time, because time, again, with clean architecture is a very important factor. You might have started this general utils with the best intentions, because it was just a tiny bit of code and a tiny unimportant package. But then the next developer comes, looks for a place for his new great code to live. And there he sees your general utils. Looks like a great place for his code or her code to live in. And this is what happens. These components with very unspecific names, they will over time grow towards really a low cohesive systems. So clean names really, really matter. Really spend a lot of time thinking about the perfect name. And do this in the team. And focus on business names. Discuss this. To give you a private example of me, I once discussed a simple variable name for 2 hours with a colleague. And hardly anyone would maybe understand this. Well, this time is really invested wisely, because if there's a disagreement, if there's a misunderstanding, there's usually a reason. And you have to find the reason. You have to get a deeper understanding of how the business works, you have to discuss this with the business guys. And you have to all agree on this name. This is what in domain-driven design is called the ubiquitous language. I don't really like this word, ubiquitous language. It's really awkward. But it's really important to have clean names, to have very precise names that everyone understands. This is how you can achieve high cohesion. And this is then again how you can achieve a clean architecture. Obviously, this is a moving target, because assuming we're working in a successful business, the business evolves because the world changes. And when this happens, our software has to change. So what was highly cohesive and a great name today might not be so great tomorrow. So the only way you can counter this is you have to continuously touch and refactor your code. And I know, this is about fear, right? We are agile, so we're not touching our code. This is not how it works. This is not how you can achieve a clean architecture. You have to continuously refactor your code and touch your code. It's the same with shaping our bodies, right? It's a factor of time. It's not enough to once go to the gym. You will eat again, and you will get fat again. And that's the same with our systems. We have to continuously touch them. This is so important. Yes, touching the code is risky, but not touching the code is even much more risky. So please do that. Rename your entities whenever you get new insights, when the business changes, because also you will never get this perfectly right? Because it is so difficult. So just choose the best name that you can come up with, discussing that, and when you better understand how the system works, you can touch the code. Software is soft, you can change it, that's great, we just have to do it. Okay, so you see I'm really getting emotional here because this is really so important to me. This is, what defines me as a clean coder. Okay, so to finish off, let me talk about size. Size really matters, pun intended. Because so far, let's recapitulate. I talked about coupling, I talked about cohesion, I talked about encapsulation and names. And I guess I very often said that's very difficult, that's very hard. It is. Now size is a bit different. Because size, and obviously I'm speaking of small size, is about simplicity. And everything that we did so far was about fighting complexity. And I said this always comes at a price. But simplicity comes for free. Getting simplicity right is obviously hard, but as soon as you have achieved it, it comes for free. So one way to achieve simplicity is by keeping your components small. When you do so, everything gets more simpler. Because think of a method of 500 lines of code. What name can you give it? It will be very difficult, right? But if you have a method, 3 lines only, you will find the perfect precise name, I'm sure. Same for a class, same for a package, same for a module, right? So size really matters. Same for cohesion, same for encapsulation, and same for coupling. The more there is, the more complex everything gets, and the more complex every other factor gets. And this is why I would like, this is my pragmatic craftsman approach. To achieve a clean architecture, I would define upper limits in your team for a method, for a class, for a package, for a module. I say this quite often, and when I say this, this easily gets very heated because people say, oh, how can you give this an upper limit of this or that size, right? I would disagree. Well, that's fine, you can disagree. It doesn't really matter that you say a class has to be of that exact size. What matters first and foremost is that you have an upper limit. But this upper limit should not be a weapon. I very often see that tools are used as weapons, right? We define, this is the rule, and when you violate this rule, then you're wrong, then I kill you, right? No, it's a tool. It should, keep your goal in mind. Our goal is not keeping the size. Our goal is achieving a clean architecture. Our goal is making the client happy. That is the first and most important goal. Everything else is just a way to achieve this. And if you find a simple pragmatic way of how you can achieve this upper goal, then this is way more important than any rule, right? So if you have a method and you have a rule that says the method must be of this size at a maximum, but you don't find a way of how you can achieve that, and the method looks clean to you, it's testable, it's maintainable, everyone understands it, and you discuss that in a team. And in a team you can agree, this is fine. Well then fine, violate the rule, doesn't matter, right? Stay pragmatic. Just keep it as like an indicator, is this okay or not? Because the cool thing is when you have these upper limits, you have a goal. Without that, you don't have a goal, but if you have it, you have something that you try to achieve. But this does not mean that you want to achieve it under all circumstances. It's just the goal on the way to achieve a clean architecture. Okay, so. Now to close. Let me cite David Parnas. He made this quote, and I really like this, and I think it perfectly sums up what I wanted to tell you in my talk. He said, I would advise students to pay more attention to the fundamental ideas rather than the latest technology. The technology will be out of date before they graduate. Fundamental ideas never get out of date. And I think this is really so true because, like, well, obviously there are all these fancy technologies, right? Spring 5 we heard from Jürgen. Well, cool, really cool. This is all helpful, but to achieve a clean architecture, you don't necessarily need all these great new technologies. You need very few things. You need very simple things. You need these bare, very old concepts from 60 years ago. This is all you need to achieve a clean architecture. It's not the big things, it's the small things that matter. Obviously, you need a lot of passion. You need a lot of hard work and love that you put into that system to achieve a clean architecture. And you have to continuously work on that. It's not enough to just do this once and happy and everything is good. You have to continuously do that every day, every minute. You have to refactor the code. But this is the way to go, and this is how you can achieve a clean architecture. So I'm sorry that I could not give you the rule of thumb. You know, you might have had the idea that you leave the room and you have a list that you can just follow. This is what Marcus told me. So on Monday I will just follow this and I will have the clean architecture. I cannot do that. It's not so simple. I know humans love simple solutions to complex problems, but that's not how it works. A complex problem is achieving a clean architecture. And such a complex problem is also complex to solve. Complex herein, this takes time. It's not done tomorrow. And this will follow you for the entire lifetime of the system. But the cool thing is, you don't need all these technologies. You just need to focus on these simple concepts to achieve it. So this is what I wanted to tell you in my talk. Thank you.
Thank you very much, Marcus. If you have any questions, please give up your hands. Okay.
Yes?
1 minute. Встаем, представляемся и задаем вопрос.
Hello, my name is Misha and I'm from Valley Corporation. It's a kind of American publisher, and so I wanted to ask you, you said a lot about clean code and clean architecture, and I wanted to ask you, what do you think about these tasks like Java puzzlers with unclear features of Java and trying to assess developers by how do they deal with these puzzlers and with these features? Did you understand me?
Not fully.
Okay, if you go outside, there are tons of different tasks. You can try to write your code in Java and so on. There's they're trying to assess unclear features of Java technology, trying to deal with null pointers and all this tricky stuff. And so what do you think about assessing developers by this stuff?
Is it a question about what the knowledge a developer has and what the knowledge is required to decide should the developer be on my team or not?
Yeah.
Well, that's a big question, so I can't give you the one answer, so I give you a short answer and we might further clarify this later in the discussion zone, right? Because it's a really big question, but Well, knowledge matters also a lot, right? If you don't have the knowledge required, then you cannot achieve a clean architecture. So if I hire someone, then obviously I check if like this person has a lot of knowledge. It requires a lot of knowledge, but like if you want to know like specific technology, well, it depends how you're using that technology, right? And again, there it depends like how much, if there's something missing, how much is missing. So I have to decide that on a case by case.
How do you assess the quality of developer?
Sorry?
How do you assess the quality of developer?
Well, there's like, I can just give you a quick answer. For example, I have some interesting things that only few know. For example, explaining volatile. Well, this is hardly ever needed because like volatile in the average system is not needed. From my perspective, we discussed this even yesterday with the other speakers. I think this is an indicator. Just, you know, it's about indicators, as I also said in my talk. This is an indicator that shows me, oh, this person even knows about this. So there is a high chance that this person really knows a lot, right? But this is pragmatic. You can't have the answer. You will have to find out. So.
Okay. Thank you very much.
Yeah, we can talk later more.
Okay, thank you.
Hello, my name is Stas. I'm from Yandex, and I'm also an advocate of clean code. Thank you for your speech. I wanted to ask you one thing. It is an investment we need to do to make the clean architecture and clean code, and it gives us. It's worth it when the project is long term. But not all the projects are long-term, and we don't know sometimes how long it will work and so on. So what would you recommend, which approach to take in this case when the future of the project is unknown? Thank you.
Okay, interesting. First of all, I don't understand why you would say, like, this is only short term, right? Because assuming you're doing a software, I would assume you want to solve a problem of a business, and we would be optimistic that the business keeps running, right? I mean, you're kind of saying, well, we already know this is going to fail. Well, then we would probably not start the whole thing, right? So if I start something, then I would really be optimistic to think this is going to exist for a long time, whatever long means, right? So, but there again, it's obviously a case by case. I don't know, did I answer? It's really hard to answer. Or can you like add maybe something?
Sometimes we don't know whether it will work. We need to try it and to see whether it will work in one market.
Well, maybe you started too early. Like, how can you like start something that you don't know if it works? Then maybe you have to talk more. This is also my experience, people don't talk enough, right? Just, oh, I guess I understood it, let's just start. No, you know, you really have to understand this. So if you're not able to define what has to be done, if you're not able to write a test that proves like, oh, this is what the business says they wanted, and you know, they understand even what I'm saying, then maybe it's not a good idea to start this at all.
You may treat it something like a prototype of some project to see whether
I'm really not a friend of prototype, to be honest, because prototype, you start it as a prototype and they will go to production. That's my experience.
Еще вопросы?
Yes, hello, thank you for the presentation. My name is Victor, I'm from St. Petersburg, I'm from here, T-Systems. So there is a perfect book called Perfect Code from Steve McDonnell. And in this book, there are many chapters regarding all these levels that you mentioned, methods, classes, packages, and so on. And in the end of each chapter, the author, he gathers all the questions that you should ask about your code to make sure that it fulfills all the requirements of a clean code. So you said that you cannot give us a rule what we should particularly do to make our code clean. But I received an understanding from this book that maybe it's not a matter of a rule, but an ability to give proper questions, to ask proper questions. So maybe, do you agree that it's a good advice, make good questions about your code, like, is my class really making a single, well, corresponds to single responsibility principle? That's a good question, and you can answer yes or no. And the rule, like, just keep your class single responsible. It gives no actual help. So do you agree that making proper questions, that's a good advice for a developer?
Asking questions is always a good idea, right? Because asking questions is about talking. Oh, sorry.
So isn't it a good rule to make your code better?
Yeah, I mean, asking questions is always a good idea because asking questions is about knowledge, right? What you're doing there is like you're trying to understand, you're trying to get a deeper understanding, and you have to get a deeper understanding. So asking these kind of questions is one approach of how, like, you know, there are many approaches, but, you know, the idea is just you're gathering knowledge, and that's good. And when you see, like, this is bad, well, then you change it. That's the essence, yes.